I'm really sorry that I cannot be there in person today. Childcare interferes with that, sadly. But I'm Leah. I am in the School of Metallurgy and Materials at the University of Birmingham, and I lead the MSc Space Engineering program, which has its inaugural year this year. And so I'm just going to start with a little bit of context about where the module sits. So the MSc Space Engineering, I think, probably the structure is familiar to everyone. I don't think there's a tremendous amount of variety in one-year taught master's programs, but I will go through it anyway. So it is full-time. It requires a 2-1 in a related subject, so physical science or engineering. At the moment, because of the size of the program, I'm able to handle all of the admissions myself, but at some point that is probably going to have to change, as I will be able to, once we get over several hundred applications, I probably won't be able to process them individually myself. It starts in September, at the end of September, at the same time as the undergraduate courses, and so the MSc students are partially kind of integrated with the students on our aerospace engineering course who are doing their 4th year of their integrated master's degree. So the students take 180 credits over the year. There are 7 taught modules in semesters 1 and 2 that they must take, 120 credits worth, and they do a research project which starts in March-ish and runs through to the end of August. Okay, so the modules in the course are laid out as shown on this slide. So in semester 1, they take 4 compulsory modules. Sorry about all the acronyms, but it doesn't. The stuff doesn't fit on there. I'll say short some of them. So they take space mission analysis and design, comms ethics and teamwork, space environment, and materials and manufacturing from space. And then they have a choice in semester 2 of 3 20-credit modules. They can take CubeSat design, human spaceflight sheet, spacecraft mechanical design, space propulsion and power systems, and sat comms. And so the ones that are in colored boxes, the colors, don't mind the colors, but they are shared across the aerospace engineering course as well. And this is purely due to the number of staff that we have teaching on the MSc. In addition to me, there are a few others, but it really is kind of, at the moment, a one-woman band. So the CubeSat design module is optional. All of the students who took the MSc this year decided to take it. So that was quite nice. Had a lovely group, and they've kind of helped to shape what happened during the module, which I'll come on to in a second. So the plan, the original plan for this module was for it to be a 4-week intensive module using a 1 UPM CubeSat, which was co-designed with ISIS in the Netherlands. And you can see me holding the actual structure there. As you can see, it's very open, so it's very easy to get to all the harnessing and the connectors, which is part of what I wanted out of it. And the plan was for them to be able to use this and handle it as we went through the module. Right. So this was purchased in August of 2022. The training, which you can see me at there, took place in January of 2023, and the whole thing was ready to ship about 6 months later. Now we ran up against reality. And unfortunately, reality was not kind to us in the form of export control. So this is finally being sorted. I am hopeful of having it in my hands before the current students actually leave, so they'll get a chance to have some have a go with it, even if they aren't actually being formally assessed on it. But yes, we had a little problem with being denied an export license and having to go through the whole process again. So the students learned a little something there, as well as me. That's late plans and all of that. So what do? Instead, I had a little brainstorm and decided to use some flown bits from a Rexus mission from 2018. And what I had from this was 2 pieces of hardware, the flown experiment and a benchtop model, which differed in design and materials from the flown model, which is quite interesting. I had an old PhD thesis which described quite a lot of the sort of output from the experiment, and we had no mechanical drawings at all. So what I asked the students to do was to disassemble what they did have, the very beat up flown experiment, and create some drawings and then reassemble it. So this is just a little sped up video of them working in the lab. This is them taking it apart. And I think one of the things that's nice about this video is that I know it's really quick, but it shows how they worked together and how they decided to kind of share out the tasks, and that they were that they kind of self-assembled, I guess, into a team. And, I really didn't give them loads of guidance. I just said, here is an object, flown experiment. Here's what what its purpose was, and kind of here's some tools for you to use, and you work out the best way that you can think of to take it apart so that you'll be able to put it back together at the end. And so they were very thorough. They did a lot of recording, and both written and photographic evidence. And although they did make a few mistakes, they did have bits left over when they reassembled it. Not too many, but they did have some. Okay, so the next slide shows them just finishing off reassembling it. And yeah, putting it all back together. See how pleased they all are. So it was, it took them quite a while to do all this. So the disassembling took two full lab sessions, and the reassembly took about 1 3/4 of those 2 to 3 hour lab sessions. So they really did take their time, and recorded everything properly. They had they set up a kind of hub, almost like a GitHub on OneDrive for all their documentation. And they took it all quite seriously. So it was, I thought it was quite successful. At least they got to do, some mechanical work, which is what they all wanted. They got to do some mechanical handling of space hardware, even though it wasn't the thing that I was hoping for them to actually use. So, sorry, I'm just replaying this. I'll go to the next one. So how do we assess them? So the assessment I split into, we conducted it as a design review. And they gave, the weighting was 50-50 between the report and the presentation. I'm going to talk about that a little bit at the end, the kind of reasoning behind that. So it's 100% coursework, and they did this as a group project in the same way that they did the labs, and provided them with templates for the report and for their project management toolbox, although not for the presentation. Now, I had an extremely strong group of students who gelled really well as a cohort. And so I think I got away with not giving them a presentation template this year. I think I probably will add one next year, just because I'm not entirely certain who's coming and who's not. I'm expecting somewhere between 2 and 3 times as many students as I had this year. And I think in order to kind of level the playing field and make sure that they spend their time on the content and not on the structure, I probably will provide them with a presentation template next year. Okay, so the reason for giving the presentation first was to give them an opportunity to implement feedback from the semester 1 group presentation. So in that list of modules that I showed you at the beginning, there's a comms, ethics, and teamwork module, and the students give a group presentation at the end of that. And they were able to take some of what I've told them and kind of some of the issues that they had with the way that the flow of what they presented and the way that they decided to structure their presentation. I could see the progression between that module and this one, which was really satisfying, both for me and for them. I was able to raise Rostov, an industrial advisory board member, to attend their presentation, which gave it for them a sort of authentic feel. They really appreciated that. The person who came was very engaged and recorded the questions, and hopefully, they seem to think so, that a week was sufficient time. They could implement any changes they wanted to make based on the presentation feedback before they submitted the report. So the design report was submitted a week later. The template was given. I'll show you what the template looked like. It's page limited rather than word count limited, and so they get 10 pages plus 10 pages per group member. I actually let this particular group of students go a little bit over because I was happy with the quality of their work, and I wanted them to give me a little bit more on what the very, very thorough amount of stuff that they did. So discouraged annexes and instead made provision for an electronic data pack submission, so they could submit any CAD drawings or anything like that they wanted to, was submitted separately from, sorry, not CAD drawings, but CAD models. And any calculations that they did, sort of more complex calculations around orbital trajectory modeling, they submitted that all separately and only put what they wanted to present into the report. So this is what the template looks like. It really is pretty thorough, I think. It looks a bit like the ones that you get from journal articles. If you use LaTeX, they often look like this, and they show what tables and figures and referencing formatting should look like. And I like this because, especially for an intensive module where students have to pack quite a bit into a short period of time, it takes away the need for them to come up with a structure on their own. And then for the project management toolbox, this was not summatively assessed, but it gave an idea for the individual portion of the assessment mark for the report. It gave a good idea of who did what and how they planned out their work. So I feel that this, even though this is not actually marked, it helped to generate that individual portion of the group mark. So what they did was they decided to do a sign project based on drag sail, and most drag sails kind of have the structure that are shown in these set of images. Set of 4 deployable booms that are offset from the main body of the spacecraft with 4 thin found panels with a fixed area. So they decided to look at something a little different. They wanted to look at a drag sail that deployed basically by popping a lid off of a 3U CubeSat. And also, the kind of one of the neat little novelties of this design is the idea that there would be weighting across the body of the spacecraft to allow the use of gravity gradient stabilization of a sail that's long enough. So they did quite a bit of modeling on this, but they did a lot of materials modeling, they did CAD modeling, and they did some other space systems modeling on the link budget and the actual space operations. I'm not going to show you any of that because it would take ages. I just wanted to kind of explain what they did with the knowledge that they got from doing the mechanical handling. So the feedback that I got from them on the experience of doing the module is that they found presenting the industry, that because they knew they were going to do that, was really motivational. They found the actual experience of it really useful. They found that because they worked together already in semester 1 on a group presentation, it made the submission of the creation of the semester 2 group presentation and submission a lot smoother. They all knew each other quite well, and they kind of had a good idea of how to implement the feedback that they've been given to get themselves a higher mark. I have a couple of students in that cohort that are neurodiverse. They really appreciated the equal weighting of the presentation and the report, because a lot of times I think in our assessments we tend to weight written work more heavily than we do verbally presented work. These students found that they find that their strengths, because of their neurodiversity, and a couple of them have dyslexia and ADHD, they find it much easier to present themselves in person verbally than they do on paper. And so they really did shine during the presentation. They knew that was, they put a lot of effort into making sure that their work, they showed the best of their work in the presentation. And they did actually pretty well in the report as well. But certainly they found that it felt more equal to them, that their strengths were being played to by being able to give a presentation and having it worth a substantial amount as compared to their written work. They also found that the mechanical handling experience, even though it wasn't a CubeSat and it wasn't exactly the sort of experiment that they were going to be designing, made some of their modeling, the computational modeling that they had to do easier, because they could visualize, they'd already sort of physically touched the thing that they were designing. So I think it went well. I'm quite happy with it. I'm looking forward to being able to add the electronic design aspect into this module next year. But for the moment, I'm pretty happy with how it went, and I'm glad from the feedback from the students that they found it a useful experience and a useful addition to the MSc. Thank you for listening, and we'll stop presenting now.
Thank you, Leah.